Well, welcome everyone who's joined us today. We're delighted to have such a large crowd with us. It's a pleasure to welcome you all to today's discussion on cool, climate-safe cities, new solutions and research, part of the Energy of the Future series hosted by the Boston University Institute for Sustainable Energy. The discussion and the series is sponsored by the U.S. Green Building Council with the support of BU's student-run Energy and Sustainability Club and the Boston University Initiative on Cities. Welcome to the members of the council, the club, and all of you who have joined us today. My name is Catherine Lusk. I serve as the co-director of the BU Initiative on Cities, and we're delighted to be a longtime partner to the Institute for Sustainable Energy. I have the distinct pleasure of introducing our guests and moderating today's discussion. Just a reminder, today's webinar is being recorded and will be available on the ISC's website and YouTube channel. So first, I just want to briefly say, why do we need to focus on cooling our cities? The evidence is clear that cities are experiencing increases in the frequency and severity of extreme weather events. Cities are seeing hotter days and hotter nights, which means there's no time now in the summer months and during the evenings for our streets and our buildings and even our bodies to cool down. Heat is already the leading cause of weather-related deaths in the US over the last 30 years. Extreme heat can lead to heat stroke and stress. Research shows it also can lead to increases in preterm birth and stillbirth. Heat has even been shown to inhibit learning. Kids score lower on tests on hotter days, even compared to their own past performance. And all of these effects I mentioned are particularly acute in lower income communities and communities of color. So we understand the scale of the problem and we understand some of its consequences. Let's actually talk about how we design cooler communities. And with that, I am delighted to welcome our panel of 4 terrific speakers. So first up, we'll hear from Greg Katz, our keynote speaker, who is the founder and CEO of the Smart Surfaces Coalition and president of Capital E. Greg has played a substantial role in developing the clean energy and green building industry, is a longtime thought leader and investor in the transition to low carbon economy, and author of Greening Our Built World, Costs, Benefits, and Strategies. After Greg, we'll also hear from Lucy Hutira, professor of Earth and Environment from Boston University. Professor Hutira specializes in urban climate and biogeochemistry, remote sensing, and vegetation ecology. Trained as a physical scientist, she has increasingly focused on the climate and ecology of cities, working at the science policy interface. She's a national leader on measuring and monitoring urban greenhouse gas fluxes and analyzing carbon cycling in cities, and I'm delighted to have collaborated with Lucy in many ways over the years. We're also joined by a BU alum, Raul Mulpuri, CEO of View, which builds dynamic glass that acts like a building's digital skin. As I mentioned, he's a BU College of Engineering alum. Dr. Mulpuri has served as CEO of View since 2008. He previously held several executive positions at Novella Systems, most recently as president of Novella Systems Japan, and Vice President General Manager of the Integrated Metals business. And finally, Jennifer Roberts, the former mayor of Charlotte, North Carolina, and a Smart Surfaces Coalition steering committee member. Mayor Roberts has been a lifelong advocate for clean air and water and for environmental justice. As mayor of Charlotte, she signed the Mayor's Climate Pledge and introduced a clean energy resolution for the city. So I'm going to turn it over to our panelists to present. We'll have a brief moderated discussion. I'll throw some questions out to all of them, and then I will open it up for audience questions. We will have ample time for audience Q&A. Please use the Q&A function that you see at the bottom of the screen at any point to share your questions. The speakers and I will both be keeping a close eye on that, and then I'll be sure to cover as many of the questions as I can toward the end. So with that, Greg, it's a pleasure to turn it over to you.
Thank you very much. Great to be on this program with you. You're absolutely right. There is no more urgent problem than our cities. And what I'd like to do today is talk about smart surfaces as a general strategy. And so we're going to focus on Baltimore as an example of an American city. It's a mid-sized city in a central zone that is certainly struggling with issues that cities struggle with today, including equity and excess heat. One of the challenges that cities face is with global warming, the number of hot summer days is shifting to the right in this, which is really saying that what had been an occasional threat to human health will become a normal summer threat to human health. National Academy of Sciences publication recently suggested hundreds of millions of people within 20 years will be living in places that cannot sustain human life without air conditioning. And if you're in a low income community or worry about power failure, that's a problem. That will drive huge migration, which creates a lot of instability. In our specific work in Baltimore, as an example city, we're doing work in Stockton. We've done similar work in a range of cities like El Paso and Philadelphia. What we find is that adoption of what we call smart surfaces, by which I mean reflective, so they're bouncing light into space, porous, so they capture rainwater and put it into groundwater recharge, green surfaces like roofs or bioswales, trees and solar PV on roofs or parking lots. That set of strategies, if adopted citywide, could deliver a lot of value, including, as this slide shows, 4.3 degrees of summer heat peak reduction. The benefits, including in health, one of our principal and founding partner, one of our founding partners, the American Public Health Association, the CEO of that, who's a medical doctor, talks about this really passionately and persuasively. This is one of the huge undercounted health costs in this country, is the result of excess urban heat and pollution. So here's a snapshot of a city, big impact on present value. It's a 10-to-1 benefit cost ratio, very job creative, big CO2 reduction, and large temperature reduction. Baltimore, like most cities, is characterized by what I would call gross structural inequality. So if you look here in the center of this map of Baltimore, you're seeing an ambient temperature of around 100. If you go north into Roland Park, which is a predominantly white, wealthy neighborhood, surprise, surprise, 14 degrees cooler. That's partly because of trees, partly less dark surface. So imagine raising a child in an environment that's ambient 14 degrees hotter, much less shade, much more radiant heat, worse air quality, including smog. That structural inequality is the reality for tens of millions of children in America today. They live in environments that are basically very hard to be outside in. And when they do go outside, they risk overheating. What else does this mean? It means you don't have eyes on the streets. That impacts crime. It's harder to exercise. That impacts diabetes, obesity, and a series of other huge risk burdens. Again, smart surfaces, this series here, reflective, green, porous on the left, solar, trees on the right. This is a resurfacing as one of our initiatives. There are 15 cities that are now resurfacing their roads and reducing ambient temperature in the adjacent neighborhoods by a couple degrees. And then at the bottom, and I know this is an area that BU's done a lot of work in, is these types of PV strategies. When you put PV on a green roof or a cool roof, the temperature of PV is less, so it actually generates more power. So what we did for Baltimore is we built a virtual model of the city's surfaces, highly detailed. And then we said, what if we apply a series of measures to them? So this would be low slope flat roofs, 80% would become reflective. And when you run through the benefits, we just talked about these, a benefit cost ratio of 15-to-1. You can see the total cost here in the bottom left are pretty small. Total benefits are very large. And when you discount future benefits to get to a net present value, you're still ending up with a 13-to-1 benefit cost ratio. The head of tourism for Baltimore is like so excited about this because they worry about tourism. Already tourism in the summer in Baltimore is reduced because of excess heat. This provides a strategy for the city to cool by 4 or 5 degrees, meaning the city can get on a pathway that's very cost effective so that the city cools 10 times faster than background heat increase from global warming. It's a citywide solution, highly cost effective, huge health benefits, addresses climate, protects tourism, and that's the impact on jobs is sort of 2 or 3% jobs in the city. Just to highlight why this reflective is such a big deal, if you look at this graph here, on the left, you have a dark roof. Incoming sunlight hits that roof, and what it does is it absorbs almost all the incoming sunlight, which is then reflected out into the city to heat the city. It's absorbed into the building, which increases air conditioning load. By the way, most of deaths, excess heat deaths, top floor, dark roof, low income, under air conditioned. Moving to the right panel, if you put a highly reflective surface on, you're bouncing most of that light back up. Most of that light then exits the atmosphere. It's called radiative cooling. So it has a big climate change impact at the city level. It has a big temperature reduction impact. Every 1 degree of ambient temperature reduction is a 3.5% reduction in peak AC load. So now you're affecting energy bills as well as quality of life. So this transition on the left from dark surface, which is lowest first cost, to on the right, a highly reflective surface is a hugely important strategy in smart surfaces. When you add some of these measures into a strategy development for a city like Baltimore, Stockton, we're completing right now in California, you're addressing surfaces through these kinds of reflective surfaces. You're adding solar PV, you're managing groundwater through this kind of ground cover. A lot of expensive parking lots and low use roads, very green paving or pavers, which are less expensive, more reflective, capture the water and are greener. So you're cleaning the air as well. Similarly, green roofs, trees, obviously managing rain, providing shade. And then again, a little bit more detail on what it means to adopt it. Well, one of the things that happens when you adopt these strategies is you're reducing ambient temperature. So trees, 10% absolute increase in trees equates to a 1.1 degree Fahrenheit ambient peak temperature reduction in the summer. This summary chart represents the 10 specific highest impact measures we selected for and with Baltimore. So reflective roofs on the left, we talked about both for low slope, mostly commercial, as well as steep slope, mostly residential. Next column in red, you see what the capital cost would be for doing that. Next to it, you see the benefits, which are much larger, the net present value, and then you're looking at the benefit cost ratio of about 7:1, and the associated temperature reduction. Going back to the left side, bioswales, green roofs, solar PV, reflective parking. These are very cost-effective measures. These are all technologies that are available today. And so this is an example of a city that's in a central climate zone in the US, where adopting this set of measures addresses some of the most fundamental challenges the city has and other cities have. First of all, ambient temperature reduction. 2, employment benefit. 3, health. You can imagine a lot of the summer visits to hospitals result from extreme heat. People are like, I don't know where to go. It's really hot, so I'm going to check into the hospital. So I go into emergency care. But by the way, I don't have insurance. Well, who pays for that? That's a very, very expensive. It's much, much cheaper to do citywide cooling. So these are just some quotes about it. The one on the top right from Georges Benjamin, who serves on the steering committee with Jennifer and I of the Smart Surfaces Coalition. By the way, our steering committee ranges from the CEO of the American Public Health Association through the CEO of the World Cement Association. It's a very broad set of organizations committing to accelerating the strategy of citywide smart surfaces adoption globally. The bottom is Chris Reel, who's head of Baltimore Tourism Association. He's like, we have to do this to protect tourism. So again, what is the strategy of Smart Surface Coalition? You think about a single framework. All of these are how we manage sun and rain. So when I look at the city from the top down, the satellite perspective, I see a bunch of surfaces. On average, American cities have an albedo of 0.18, which means they absorb 82% of the incoming heat and turn it into stuff we don't want, right? Excess heat, pollution, and heat deaths. We mismanage the rain as well. What if we managed our surfaces so that we could use rain and sun to make our city healthier and happier. That's really what we're arguing for. And we've built a tool set and a very powerful coalition of organization, leading health group in the country, leading planning group, leading architecture group, blah, 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 to drive this across cities. This is a city after you do green surfaces. And then this is our this is our steering committee and the board of directors. And so we're really delighted to be able to present this here to you today. You guys do fantastic work, both as an organization and people like Professor Hucha. So thank you for the time.
Great, Craig. I want to throw one question out to you before we move on to Lucy. You mentioned, well, maybe I might lob two questions at you. You mentioned the real need for cities to think comprehensively and the potential risk that they think in terms of a single solution. And so I'm wondering if you can talk a little bit about the coalition's work more generally. Are you trying to not just sort of align and serve as an ally to cities, but are you actually trying to change the mindset and the way that cities are approaching their work so that even heat and water are part of a comprehensive plan? I mean, one of the things that we're learning as we do interviews with mayors across the country is that they're increasingly paying attention to heat, right? They've been focused on flooding, but heat and the many, many, many risks that are posed by heat is sort of increasing in awareness among sort of mayors' offices across the country. But it feels like early days in so many places where there are this approach of sort of a single solution rather than a comprehensive plan. Can you kind of comment on what you're seeing and potentially the role you're trying to play in changing sort of mindset and approach?
Yeah, it's a great question. We've spent billions of dollars of grant money and foundation money in the last 25 years on pilots and subsidies to accelerate, green roofs and reflective surfaces. And 25 years later, cities are hotter, darker, more impervious, more unequal, more unhealthy, and with less trees. That's a strategy. Obviously, it's not working. Why is it not working? Because mayors, so there's 18,000 cities and towns are part of the National League of Cities, which is the leading cities group. 99, basically every city there, you talk to them and say, look, are you interested in health and reducing energy bills and stuff? And they're like, yeah, absolutely. Well, who makes a surface decision? Gosh, I think that must be the Department of Transportation. Okay, we walk over to the Department of Transportation. We say, do you ever think about heat or health or jobs or climate when you make these surface decisions? No, we never do that. We only think about lowest cost. So there's this huge breakdown between what the intent is and what is actually done. So to solve for that, you have to handhold cities through this process where they reframe thinking about these on a, gosh, we're just going to keep doing surfaces in the way we've always done it, lowest first cost, which is dark, impervious, stupid surfaces. And we're going to make a conscious decision to make surface decisions based on how do we protect our city. And so, as I said, one of our initiatives, we have 15 cities are resurfacing roads in pilots. Manny Diaz, a former mayor of Miami, said, cities want to be the first. And then he stopped and he said, as long as it's been done before. The second piece of that, as long as it's been done before, is about risk management. So when you have all the leading organizations that cities look to for guidance, saying the same thing, stop doing stupid surfaces, start doing smart surfaces, adopt a strategy that can cool your city 10 times faster than the world is warming. That's an interesting proposition. There's a 3-part series on our website in Risk and Insurance, the industry leading publication that talks about and demonstrates how smart surfaces protects your city credit rating. In other words, your access to low cost capital through bond markets. Standard & Poor's and Moody's have made it very clear they're considering this in city valuation. So the CFO of any city is going to say, oh my gosh, we have to have access to low cost capital. If this is a strategy to protect it, let's adopt it. So we're pursuing a lot of different approaches to enable and support and encourage cities to make this transition from stupid surface decisions, unconscious, to making it a conscious decision through packaging it, through support, through the analytic tools, cost benefit analysis to help this transition happen fast. They have to do it, otherwise cities get stuck with more air conditioners that spew heat into the cities. So it's really private cooling versus public cooling. Public cooling is vastly cheaper and doesn't have, painful co-costs. It has co-benefits.
Right. I'm going to stop you there because I appreciate that framing and a shift in mindset from private cooling to public cooling. I've not actually heard it described that way. I think that's a compelling argument for our public officials. And so I want to pivot to Professor Gutierrez so that we can talk a little bit more about some of these mechanisms on public cooling. And then I want to come back. A reminder to everybody, please be submitting your questions in the Q&A and I'll keep an eye on them. And I want to come back to some of the mechanics of how you really operationalize this work, Greg. But I'm going to put a pin in it for now and turn us to Lucy, if that's okay.
Thank you, Catherine, and thank you very much for inviting me to join you today. So I really appreciate Greg's comments, and he really set up a lot of what I have been to share with you very nicely. I take a rather different perspective. I think that the suite of solutions that Greg laid out are excellent. But I'll talk to you a little bit more about what we see actually happening in cities. And my phone is ringing, sorry about that. What we see actually happening in cities and thinking about where we prioritize making changes first. So this is one of my favorite pictures of Boston. You can see the Commonwealth Avenue Mall, you can see the Public Garden, the Boston Common, you see the city of Boston surrounding it. This is a great image of what a lot of people want cities to look more and more like. And I want you to keep this image in mind as I shift to this scene here, which shows the city of Boston. And this panel here on the left is showing land surface temperature. This is measured from a satellite. The darker the color, the hotter the temperature. You see that it's uneven. Greg told us a bit about the warming that's happening, and this puts some of that in a visual of how uneven it is. There's racial disparities, there's income disparities, there's huge land use differences that underlie these patterns. At the same time, this image here that's on the right shows the current distribution of canopy cover across Boston, so tree cover. That picture that I showed you at the beginning is right here. This is the Public Garden and the Commonwealth Avenue and the mall and the Boston Common. It is one of the greenest parts of Boston that you have. And this is a great ambition for what we could make more of our cities look like. But we have a very long way to go if we look across the city. And what do we prioritize on our path to get there? So I want to touch on a few different solutions. First and foremost, we need to address the root cause. We need to reduce greenhouse gas emissions and stop. That's the fundamental problem. We need to tackle that. We need to adapt. And I have a little bit of a different view than Greg on air conditioning. I think that cooling for the public is definitely what we need to be doing, but that'll take time. And in the interim, I think we also need to think about different kinds of solutions that can be implemented now. And some of that is air conditioning. That's something of a taboo topic, but we can reduce some of these premature excess deaths and illnesses. We can also take much lower tech solutions. We can add blinds to buildings. We can require that apartment buildings can have blinds and reduce the incident radiation that's coming into buildings. We can adapt our environment in different ways to tackle this problem. Green infrastructure. That is what I'll focus most of the rest of my comments on, is a great way to address this, but it's a complicated one. And I'll look a little bit at some of these complications. This image that I have here on the right is an artist's rendering of what my university will hopefully look like in a few years. I don't have the current image. It looks nothing like this yet. And we have a ways to go to get there, and we have to decide, what are we going to do first, or what are we going to do in parallel, and where are we going to do it? And the cool building materials and those highly reflective surfaces that Greg mentioned are a really key piece of this puzzle. And which of these solutions gets implemented where and when is, I think, one of the key things that needs to be happening as we continue to tackle this, but number one has to be happening everywhere. So I'm a professor, so I will give a really brief tutorial on how this green infrastructure actually works and what we're seeing across cities. So here's my happy little tree. My happy little tree is in the sun. And what these trees do for us in the city is, first, they shade. So they block radiation from hitting the surface, getting absorbed by that surface, and that energy to then be re-radiated at night. This is great. This is often what we think of when we think of what trees are doing in the city. But the dominant way that trees actually cool is the process of taking up carbon dioxide. Plants, when they open the pores inside their leaves to take up CO2 and do photosynthesis, they release water. They take liquid water from the soil, they move it through the plant, and it gets evaporated out of the plant. When that happens, that water going from liquid water to a gas consumes heat and cools the city. And when we think about trees as solutions, we need to be thinking about both of these mechanisms that are in play and how viable are they for your city? Do you have the water available to support the trees? Do you have the water available to support the green space? And this happy little tree is only one of the forms of green space that we have in our city. Here's a picture of Boston City Hall roof, nice green roof. And a lot of the green space that we actually have in our cities today is grass. And grass, if it's green and lush like this, certainly performs these same functions and does evaporate water. But a lot of our grass and trees look a little more like this, where they're brown and they're not evaporating a lot of water. Or the trees are small, and the amount of shading and cooling that this tree will provide is maybe not what you might imagine when you look at this. And trees take time. The best time to have planted a tree was 30 years ago because it might look a little more like this. And trees, I wholeheartedly believe, are part of the solution, but that it will take time for trees to really have an impact. So I want to share with you a little bit of data that one of my students has been working on. This is work from my student Ian Smith. And we've been partnering with the city of Boston in some of their heat resiliency planning and trying to think about what to do where and when. And this graph has a lot of data. I'll walk you through it. So what's plotted here is the land surface temperature. So how hot is the surface? This is measured from a satellite. We have a long record of how the surface temperature is changing. And here along the X is how green is it? And this is most of the studies that have been done focus on green, not necessarily whether it's tree or grass, just green. And each little point that you see in here is a 30 by 30 meter area of Boston. So this is somebody's house or maybe a pocket park or something like that. And the brighter the color that you see here, the more red, the more places you have that look like that. And what you see in these areas, so these are different parts of Boston that's plotted here, in these areas that have a lot of trees, so they have at least 50% tree cover and not grass, you see a super tight relationship with the temperature cooling as the amount of green trees increases. This is great. This shows that the solution works. But in a lot of other places, if we parse this out and look at green areas that aren't trees, but green areas that are grass, it gets a lot messier. And a lot of our city actually looks like this, where the green is grass. And it turns out that in the case of Boston, and I think this is dependent on what your local climate and city looks like, trees are 43% more effective than grass at cooling. This isn't a theoretical, a beautifully irrigated greenhouse study. This is what we're seeing in the differences across the city. And But again, these trees take time. If we dig into why are some of these other non-tree green surfaces less effective, it will make total sense. So this is, again, these are just the areas that have predominantly grasses. This giant cluster of points is areas like this. This is Logan Airport. Logan Airport actually has a lot of green, right? So you can see all the paved areas of the terminals, but there's all this green space around it. This green space is doing very little in the way of cooling. This is minimally maintained and not irrigated. This is pervious, but it's not doing much in this green lawn space to cool our city. The second cluster here that you see are places like this, and that's what this cluster looks like, where we have parks and open spaces in the city. These are moderately managed and maintained. There's semi-regular water inputs or water inputs into part of it that keep it this green. And so you see that if you have some of these areas, you'll get a cooling benefit, but that cooling benefit is quite proportional to the water inputs and the management that goes into keeping those spaces. And of course, cooling is not the only reason we want parks and how we use parks, but it's something that we need to think about when we design parks as part of our solution of how much water does it take to maintain it to get some of these cooling benefits. The last example, which is out here at the extreme, is golf courses. Boston has several, and they all sort of look like this. They're fantastically green spaces, super productive green spaces with intense resource inputs to them. And these areas, the green spaces, if we look at them on those same temperature maps, are very cool because water is being added through irrigation and it's evaporating and it is cooling these spaces very beautifully. But is that how we want to cool our cities? I'm not sure that the resource inputs of a place like a golf course would be how we do it. But this gives a picture of what these different spaces across the city look like. And the cooling that we actually have is very dependent on what the vegetation there is and what the availability of water in the future looks like. This is a map that we created that looks at how much cooling, and this is plotted in energy units, which drop me an email. I can explain in full detail how that comes into play. But you can see that there's very little cooling that's actually happening in these more developed parts of the city. And then there are parts of the city here where some of the parks are and some of the more residential areas are, where there's a huge amount of cooling that's already in place. And when we think about prioritizing, where do we do what? We really have to think about what are we already getting in some of these places and what might it look like in the future? Because where these plants are actually getting their water has a huge impact on future viability. Do these trees and grasses rely on irrigation? And what happens if irrigation's not available and we're competing with irrigating our lawns with our drinking water? And as we go to the future, a lot of the benefits that these green spaces are performing may or may not continue, and we really need to think about that. And a solution for a very mesic, especially this summer rainy place like Boston, may not be the same solution as a more arid place. Because if the trees run out of water, if the trees have ample water, they will keep evaporating and they will reduce our need for something like air conditioning. If they run out of water, they may make the problem worse. And so we need to be thinking about in tree planting campaigns, not just let's plant trees, but is planting trees the right solution? Which species of trees and how are they going to be able to survive going into the future to have water resources? And the forecasts are pretty clear that by 2050, Boston's temperatures are going to look like DC. But what's much less clear to me is what our vegetation will look like. And will these solutions that we're looking at today, will we have the water resources to sustain them? So I'll stop there. And I'll go back to this list of solutions that I started with, and I'll just say that there's no magic bullet. And I think we need to be doing all of these things all of the time. But we need to think about a real place-based approach in what are the characteristics of the city, and identifying the right solution for the right place, and prioritizing places that have some of the most vulnerable and acute needs with the right solutions. So I will stop there.
Great. And Lucy, I want to throw one quick question to you from Andrew Engel from the chat, who says, what effect, if any, does the presence of bodies of water have? A pond in the middle of a park, for example, temperature along the bay, and the seaport temperature along the Charles. Because we're talking about place-based solutions and you focused on Boston, it feels like a fair question to lob at you now very quickly.
Water is great. Water will cool. Water is a dark surface, so some of that albedo effect, it's going to absorb a lot of the radiation, but in the process of absorbing it, it's going to evaporate water. It is cooler near those bodies of water. It is one of the solutions that is put forth of adding fountains and adding bodies of water as a way of cooling. It works very well if you have the water.
Mm-hmm, mm-hmm. Great. Well, I want to come back to this point because I think it warrants a good discussion with you and Greg about how might a strategy work in one place and how might it be adapted, and provide a case study. You know, the case studies that city can draw on are really based on the typology of the city itself and the characteristics and qualities of the city itself. But I want to turn it over, say thank you, Professor Hutira. And I want to turn it over to Rao.
Thank you, Catherine. And it's such an honor to be joining this panel, and especially a delight to be back at BU virtually. I'm going to give you an entrepreneur's perspective. I'm also going to talk about some things that I believe are relevant to cities and life, even equally or more than sustainability itself. While most of the attendees here we're probably preaching to the choir. There's a self-selection of people that attend these type of events because they believe in it. And as I looked at the attendee list, you have some entrepreneurs, you certainly have some city planners and people that are involved with the future of cities. I saw certainly academics, some people I recognize from BU, and of course, a lot of students. So I'm going to kind of tailor my remarks based on this audience, and perhaps be somewhat complimentary or maybe even provocative with some of my thoughts here. So with that, let me give maybe a little bit of background on myself. I spent 6 years at BU, got my master's, and then signed on for a PhD and completed my PhD in material science, working on thin films. And then moved out here to California, to the West Coast, and spent 12 years here in the Valley, driving, chasing Moore's Law. As many of you might know, the semiconductor industry is built on Moore's Law, and Moore's Law is not a law of physics. It's a prediction of rate of change. And a lot of disciplines in science enable that, which then enabled, computing, storage, connectivity, everything we enjoy today in technology. And then for the last 12 years, building View. So my comments will be based on my own experience in, learning a lot of science, but implementing it in 2 different industries, and a perspective into the world of infrastructure. So with that, let me jump right into some material. So again, as an entrepreneur and as a scientist, I like to think about, the role technology can play in creating a better life for ourselves and the generations that follow, our children, grandchildren, and so on. And we at View start with really understanding the science. And we look at 2 broad areas of science. One is understanding the human body, our physiology, our biochemistry, our psychology, and how that's impacted by many, many things around us, including the space we consume in this particular case. And then second is broadly understanding the universe. And that has 2 broad perspectives. One is the geoposition of the Earth relative to the sun, it rotating around itself, the solar system, and certainly the seasons and so on. And that brings us to climate change. But actually the periodic table, we are lucky to have a set of elements that by chance ended up on our planet. And we have the ability to, in a smart way, use those resources in order to create better life for all of us on this planet in a responsible fashion. So understanding these two broad areas of science and sometimes making the connections that others might not have connected is actually what creates an opportunity for progress going forward. If I think about broadly the area of real estate, and cities are nothing but a set of infrastructure that's put together, I see four multi-decade trends. We're at the very beginning of these trends. Clearly, sustainability is a big one. I think today, while there's been a lot of debate over decades, and even in this country, it lagged a little bit compared to places like Europe. Today, sustainability is a freight train. I mean, it's moving very, very rapidly. And that's not only young people, especially our children driving this journey, and they're recognizing the connections in science. Climate change is undeniable. Moving to net zero is something everybody's a big believer in. We see corporations, we see investment funds moving with ESG in a very forceful fashion. And of course, governments and regulation. And I know we're talking about cities here. So I think the sustainability movement is very much underway, and it's going to keep accelerating in the coming years and decades. But I'm going to bring three other perspectives that I think are important as we think about sustainability and the future of infrastructure. The first one is human experience. And I'll talk about that with a couple of graphics that are provocative. But a lot of people think about buildings as monuments and forgot about the fact that they're really built for people. At the basic level, this is shelter. I mean, we create shelter for people. Health. We've learned a lot about health, about our bodies, as I talked about the biology and learning about physiology, biochemistry, and psychology. I call it here tongue-in-cheek, space is the next frontier in health. It's the space we create for ourselves. And then computing, what's coming up with technology. As I said, we believe in technology as a force for good. So there's a lot of opportunity here to create a better quality of life for all of us. So as I was thinking about this talk, I went back and thought about what's the history of architecture? I mean, why do people build cities and buildings the way they do? And if you go back about 5,000 years, you get inspiration from the pyramids. If you go back a few hundred years, you get inspirations from places like Taj Mahal. Today, a lot of buildings, even city planning, is done like this. And unfortunately, this is only one perspective. It's buildings as monuments, not buildings as places for people to inhabit. In fact, what's remarkable about these two monuments is they were not even built for live people. They were built for dead people. And you go inside them, and I've been to both of them. You go inside these things, they're actually filled with things like lead and arsenic and things that aren't good for you. So there's still a lot of architecture that happens with this type of perspective. But I think there is a way to frame it around the experience of the user. In fact, given what I do at View is we create this digital skin to the building. I actually went and looked up the definition of a facade. You talk to any architect that builds core and shell buildings, they think about this as a facade. And there are definitions that are quite interesting. I mean, basically, it's to conceal something that's less desirable inside, right? And so it's just for young people thinking about this, there's a huge opportunity to make it transparent, to make it around people. So it's the user experience of inside out that really matters. And coming from tech, this is native to me. This is native to a lot of our colleagues here in Valley. We think about user experience around devices and everything in tech. And in buildings, there's a huge opportunity to frame the experience around the user. The second thing about health, just in the last 20, 30 years, we learned a lot about food. In academia and in research, the role of food from a health point of view has been well established. And for the longest time, and even today, the basic need for food is as fuel. If you go back 100 years ago, again, I'm going to be provocative. Rich people were fat, poor people were thin. We have the exact opposite problem today because we've created an abundance of food. So clearly, we recognize the need for food as fuel. But then taste is the thing that for the longest time that we as mammals have embraced as a quality metric for food. But just in the last 20, 30 years, we've now been educated around health. And today when we make food choices, we choose food and the quality of food based on a lens of health. And that's remarkable change just in the last 20, 30 years. If you go back, it was Whole Foods, it was Trader Joe's. I don't know if you know, but today Costco is the largest seller of organic food. So organic, fresh, low fat, low sugar. So again, learning more about our bodies, learning more about how we consume things around us, created a profound knowledge and experience around food. Likewise, in real estate, we know that at the basic level, the role of real estate is, for shelter. And shelter, by definition, is a disconnecting event, right? And then we all understand the notion of experience. And as I talked earlier, the outside in versus inside out is where the opportunity is. But the really big opportunity in space is health. We're finding connections around how our physiology, our biochemistry, and psychology are impacted by the space we consume. Specifically, the pandemic taught us the value of the quality of air we breathe, right? It's not only whether they're pathogens or not, but things like volatile organic compounds. What's in the spaces that we're creating? We live 90% of our time indoor, and we're not made to be an indoor species. It's acoustics, it's thermal comfort, it's the amount of natural light you get, because there's profound impacts of short and long-term health based on how you create space. So I think there's a tremendous opportunity to use health as a lens to create infrastructure. And then finally, I call it broadly computing, but really technology and embedded technology in buildings. Taking us back to the first generation of computers, for about 20 years, from 60s to about 80s, it was mainframe computing. And there were thousands of these in the United States, and they were central in nature. Size of big rooms were these computers that, our iPhones have more capacity than these today. And the interface was primarily punch cards and tapes. You fast forward to the next 20 years, from about 80s to about 2000, that was the era of PCs. We still use laptops, et cetera. And you went from thousands to then millions of these across the country. And the interface is keyboard and mouse. You fast forward to the next 20 years, which is the last 20 years from about 2000 to today, is the era of mobile computing. And you went from millions to now billions of these devices. Many of us have multiples of these. These either go in our pockets or in our briefcase as these tablets. And the primary interface is touch, but we also have gesture, we have facial recognition, we have voice recognition, we have AI coming up. So the question is, what's next? If you talk to everyone in big tech, they'll tell you it's the notion of ambient computing. And ambient computing is much like we're doing voice recognition, facial recognition, and gesturing. It's the ability to do computing in a more natural way than mobile, where you don't have to touch something to give a command. There'll be another 1000x of these devices. There'll be trillions of these, and multiple users can interact with multiples of these. So there's an opportunity to create infrastructure that is smart, that's connected, that's serving the people better, and it's embedded into the fabric of our infrastructure going forward. So these are the 4 big trends I thought I'll share with you. To enable these trends as a technology company, there are 4 big technology pillars we see that can enable it. Number 1 is material science. I mean, that was my training at BU. I worked on thin films, and the opportunity here is, how do you rearrange the elements in the periodic table in a way that you get more out of these materials that are beneficial to humans? The second area is high performance, low cost devices. So these are semiconductors. We used to say with Moore's law, you get more and more for less and less until you get everything for nothing. So you're going to continue to get more devices for low cost, and that's good. There's a beneficial use of that. Ubiquitous connectivity, both wired and wireless. We have 5G coming up. We have high-speed fiber. We have lots of ways we can connect these devices and ourselves better. And then finally, AI. I know it's a buzzword now, but AI is nothing but contextualization of all of these technologies in a way that we can do things in an automated fashion much, much better. So coming to what I do at View and how we think about things and how all of this comes together, as I mentioned earlier, we're fundamentally an outdoor species. Our DNA, our evolution hasn't been fast enough to keep up with us spending 90% of our times indoors. And everyone craves a view of the outdoors, right? We spend about 90% inside buildings, about 10% outside buildings, and about half of that in an automobile. If you look at the size of that industry and the type of changes that are coming up in the automobile, there's about a 20x opportunity to create a far better experience for people inside buildings. So coming to what we do at View, as I said, we think about the angle of the sun, relative to where you are positioned in a building. There is an animation that shows a rectangular building, top-down view. What's happening to the penetration of sun into the building. And as Lucy pointed out earlier, a lot of heat comes in, through the windows. And again, the windows are there for you to stay connected to the outside. In this particular case, which is actually a well-designed building from a standpoint of you being able to connect to the outside, some 73% of the entire floor space gets direct sunlight, right? And all of that is heat that comes in the form of infrared. All of that is glare that creates discomfort. So, pretty significant amount of heat and light coming in. And it's because these are actually, believe it or not, well-designed buildings, relative to the pyramids, for people to occupy. But they come with an energy penalty and they come with a comfort penalty. So what we as humans have done, and we're lucky to have discovered this what I call magical material called glass, where it's a wall you can see through. We're incredibly lucky. We wouldn't be able to live in these spaces without windows. So windows are not bad by themselves, but the technology has not evolved in order to create all these opportunities we have. And the excess daylight causes heat and glare. So then what do? We do what we're, kind of instinctively used to doing. And I know Lucy talked about blinds. By the way, Lucy, it's the only product we could ever find that's been named after a known human handicap. That's how ridiculous this product is. And so they block views, they trap heat, they collect dust and germs. You might as well not have put a window in the first place. Why didn't you just build a wall? You look at the building on the right, that's how they look. And we like to create cartoons at view. We think this will be a thing of the past. So what we did is we took a nanotech material. We took a set of elements and assembled them in a way into a thickness of about a 1 micrometer coating. So just for reference, our human hair is about 100 micrometers thick, and applied uniformly on the entire surface of the building. And what this product does, it's called Smart Glass. It automatically adjusts itself throughout the day. So it will provide the heat benefits that Lucy was talking about with blinds, but it provides the views that you need and want. It provides the heat control, and it does it in a completely automated fashion. So remember what I started with, technology can be a force for good. We can assemble the periodic table in a way that would create a far better, smarter infrastructure. The window panel itself looks identical to your regular windows. In fact, structurally, for wind loads and structure, it needs to be of certain thickness and strength. But inside it is this very dynamic, active coating. That each window has its own IP addressable microcontroller. Think about each window as an iPhone, and there's thousands of these in a building that are connected into a network, and you can manage it from your software or your app, and you can design the space to your needs. You can design it to be sustainable. You can design it to be healthy, and you can design it to be an ambient computing device for the future. And it's highly experiential. And so I think I can stop here. I wanted to provide this perspective of things in addition to sustainability, but especially show you how technology can play a role in addressing a lot of these very important societal challenges. What I think is critically important for all of us thinking about the future of infrastructure is not just how do we save the planet, how do we save the planet in a way that we can keep driving quality of life forward so that our children can live better than we have in what they actually get done inside space.
Wow, thank you so much. I'm going to throw a question at you from Lisa Cunningham in the Q&A, who asked about the insulative value of the glass. How does it compare to passive house wall value? And I'm wondering if you can also, I'm going to throw a question simultaneously, which is, can you speak to the technology and solutions you guys have come up with in the context of retrofits versus new construction, and how you find them in the context of adaptive reuse and their efficacy and adoption in adaptive reuse versus in new construction? So 2 questions to you, and then we'll turn it over to Mayor Roberts. Thanks.
Great questions. So on the first one, the insulating properties are identical to any other insulating properties of double pane or triple pane glass. In our case, we do the same as what the industry does, which is we fill it with argon. It's 2 panes of glass or 3. If you put 3, you get a better insulation in the wintertime. That's important. So what this technology does is it addresses the ability to regulate the infrared heat, the ultraviolet spectrum, and of course the visible in a smart way. And the insulating properties are identical to all the other advancements we've seen in windows. To your question on new build versus retrofit, yeah, for every one new building being built, there are 100 existing buildings. And those buildings need to be upgraded, not only for sustainability and better energy performance, but frankly, for modernization. I mean, your children won't be living in the same house you are, right? I mean, houses go through upgrades, buildings go through upgrades, airports are going through upgrades. By the way, we're doing our third improvement in Logan, in the home airport in Boston, right? And we are in about coming up very close to 100 million square feet of space in which we're either already installed or designed into. Just to give you a sense of airports, we're in Logan, we're in SFO here, we're doing LaGuardia, we're in Chicago O'Hare in the new terminal, we're in Memphis, Charlotte, I can go on and on. So a number of large airports, big health institutions, of course, offices. We have a lot of the big tech companies as our customers, educational institutions. I think we're starting to do some projects in Boston as well at BU too. So this is really for every type of building, any building in which humans interact with the outside. You really need to find a way to regulate heat, provide views, keep them comfortable. On renovations, out of about 600 buildings we've completed so far, about 150 of them are renovations. We're starting to do very large scale renovations in places like Manhattan. And that's driven by the need for owners of those buildings to get to net zero, get to sustainability goals. Cities are actually starting to levy some pretty significant penalties for being energy hogs in these buildings. But frankly, the developers, the owners have a need to modernize them so they can get a better rent, they can attract a better tenant. So there are technologies that enable you to do both, where these can leapfrog, even buildings of 5 years ago by adapting technology and renovations.
Mm-hmm, mm-hmm. I saw the Chrysler building and the view from the window that you posted. I was wondering, is there a historic retrofit that you have your eye set on someday in the future? Some of these iconic buildings even.
Yeah, maybe, iconic. One of the things I know, there are some of the regulators here, city people here, iconic, as you might know, Catherine, I think Jennifer is up next. Iconic also means there's all kinds of limits in what you can do to them. And sometimes cities and localities have these things about historic preservation, they call it, which I can imagine is a thing of heritage and so on, but it also makes it a real pain for a technology company to come and think about the occupant. So I think the thing I would urge everyone here to think about is think less about buildings as monuments and pieces of art, more about the real purpose, which is for people. Let me leave you with one final thought. That's, I think, I've been pushing this thought quite a bit with people, which is, let's agree that the most sustainable building is no building at all. Just let that absorb for a minute, right? So then if you say, I'm going to now take resources out of the earth and actually build a building, let's make it work really hard for the people.
Great, thank you so much. And we'll get back to some of these points. Mayor Roberts, I want to give you a chance to chime in. And I have a question I wanted to tee up for you, and I know you have some prepared remarks, but I'd love if you could consider what you will be doing, which is take us inside City Hall. Mayors play an important role both in influencing their own decisions, right? They have resources, they have assets, they have public assets, parks and green spaces, they have buildings, and they influence the decisions of others, right? They're elected officials, they have local policy levers and a tremendous array of opportunities to incentivize private actors to make decisions that are in the best interests of the community generally and of the individual users of their buildings and resources. I'm wondering if you could sort of peel back the curtain for us and give us a sense of what are some of the challenges that they may confront in influencing sort of their own decision-making and their own assets and resources, and some of the challenges and opportunities in influencing the decisions and actions and resources of others.
Sure, I can do that all in 10 minutes. So thanks so much for the question, and thanks to all the presenters. It's been fascinating hearing incredible science and theory and measurements and data. And what I always tell people is, in the mayor's office, that's where theory and science run into human nature, where what is possible and what might be best for your city meets what the heck can you get done? So absolutely leadership matters. And mayors and council members and county commissioners and state legislators, every single elected official has a platform, and it makes a difference if they are willing to stand up for climate mitigation, climate adaptation, and to talk about it in a way that matters at the human level. I love what Raul was saying about, buildings are for humans. That's really what mayors are looking at. However, we are in a very complicated system, and there are a lot of different authorities. There are a lot of different pushback in a lot of different ways. And I'll talk about the challenges. One of them is this whole mix of incentives versus regulation, and public and private. There is no doubt that good policy can drive the market. And we see that over and over again when we have cities who are able to get regulations passed, because there's always a pushback to requiring things that, it's longer for permitting, it's more things that developers have to do. But we've seen, requirements for energy efficiency, for cool roofs. Over a dozen cities now have implemented that. And I think Los Angeles has 50,000 cool roofs now because they implemented a policy about 10 years ago. Many other cities are watching that. I know that in Charlotte, when we were a non-attainment area based on EPA ozone standards for ground level ozone, that led to a huge change in people building out bikeways and trying to get people to walk and bike to work, trying to reduce the number of vehicles on the road. There was more carpooling. There was a lot done because that regulation was restricting the ability of the private sector to do some things. Sometimes it takes an emergency. There was a study in Houston that showed that some of their pavements were reaching 160 degrees Fahrenheit. And so that city now requires flat roofs to be reflective. Cincinnati had a heat wave in 2008. Many of its trees died. It lost a lot of its canopy. And so it implemented a very aggressive forestry plan. I love that the speaker brought up that trees need maintenance, and it's not just a simple solution. There's a lot that goes into it, the balance of water available, etc. And so there are a lot of examples where regulations absolutely have led the market. I remember being a county commissioner, Mecklenburg County, which is where Charlotte is, implemented a requirement for all of our new buildings to be LEED certified. Well, when we interviewed the contractors, we noticed that several of the architecture firms had just hired a new person who was LEED certified, who knew how to build a building. It drove the marketplace. After those architecture firms then had people who knew what LEED meant and how to implement it, more and more private buildings started following. So there's that mix of leading by example, leading by regulation, and having to work with developers. I loved the comment Raul started with talking about real estate. Cities are all about real estate. The developer community is very important in every city I've ever been in, every mayor I've talked to. You have to work with them, but sometimes you have to leave regulation. I'll give you another example. We started requiring all commercial buildings to recycle cardboard because of all the cartons and shipment and a lot of space in the landfill. So when we first voted to do that, and they were commercial buildings of a certain size, a certain volume of cardboard, we got people coming down to the county commission protesting, very upset. A year later, many of the same people came back and said, thank you, we're saving money. We are saving money, we're operating more efficiently, we can look at how we've saved cost. So some of those things, in the end, you'll be thanked for, but sometimes you have to push. And that is not always easy. The second thing I want to emphasize is that public engagement is really important. Sometimes the public can drive their leaders to do the right thing. Sometimes some of the best solutions I heard were citizens coming down and talking to us in the open forum about ideas they'd had, things they'd seen in another city. You've got so many topics thrown at you in any given day as a mayor or a council member. The public can have great input. they also can be great at helping your policies move forward. So when we work with the public, help, for example, tell them how to take care of those street trees that are in front of their property. What kind of maintenance do they need? If they aren't properly maintained, they can die, and as we heard, it can be worse. We had a program called Adopt a Stormwater Drain, because, you know, with flooding being more frequent in cities, and we know that one of the things Smart Surfaces does is look at how can we have more permeable surfaces to help reduce that risk. But when you have a whole group of citizens who've adopted a stormwater drain, not the kind of thing you can go home and tell your kids, guess what we did today? We adopted a stormwater drain. But when you have people who are helping get the debris out of the way, then you're not flooding those intersections, and you're keeping those streets safe for cars driving, for emergency vehicles, et cetera. So that public engagement is incredibly important. Another thing we see with public engagement and support for good policy is that health is a big motivator. Survey data tells us that your personal health, your family's health will drive you to act. One of the sad things we've discovered in looking at, there are many different websites that look at concentrations of chronic illness, you know, whether it's respiratory illness, asthma, incidence of stroke, et cetera. Unfortunately, those often are higher in areas, low-income areas that have been disinvested, that have been redlined, are Black, Indigenous, people of color communities. And this is where the whole idea of justice really comes in. We've seen this during COVID. We've got a neighborhood here in Charlotte that is located between two highways. And again, highways were built in low-income neighborhoods, primarily BIPOC neighborhoods. And there also was a big landfill there that homes and even a church was built on. That area of our city saw a much higher incidence of COVID, not just the illness, but also deaths. So the idea of justice, even thinking about outdoor workers, thinking about where your bus stops have shade and where they don't. You know, is it just in the wealthy parts of town where they're shaded? You know, all of these are issues of justice. Cities are really looking at justice, and it is resonating with the public as well, and with the private sector. We have seen great collaboration on those issues of justice. You talked about airports. Airports are incredibly hot places for those baggage handlers to work. And so we had an incident, we had a protest, et cetera, when it was discovered that the workers weren't being taken care of in terms of that extreme heat. So cities are thinking about, you know, where are our citizens vulnerable, and how can we be better at that? The other thing cities are really good at is the CASE system. CASE, that is copy and steal everything. And that means that we're looking at other cities. We want to see what's everybody else doing. I love the comment from the
Jennifer, does that strategy apply to your children, or is this just for cities?
We don't tell our children to steal things, but they can copy when they're not in school. You copy good ideas. You copy good ideas because, for example, I know that Boston has used public art for cooling. I found that in a Smart Cities Dive newsletter, and they reflective paint, you know, brick walls are pretty hot, but when you put reflective paint, you make a beautiful mural that helps cool that area of the city. You can also make shade structures, by the way, that are works of art that have vines growing on them, because trees take longer. Vines are pretty fast, and you can put in that physical structure. So I'm glad you liked the CASE method, Greg. So real quick, I know you want to open to questions in a minute, but I want to just give a summary of challenges that cities are facing. Inertia. When you look at our contracting departments, whether it's city, county, state, people go to the same people over and over again. You've got to break the inertia. You've got to go to innovative surfaces. You've got to go to innovative materials. You've got to try something new and different. There's an anti-regulation sentiment. We see that with mask wearing. That's real, and cities are facing that in so many areas, including climate mitigation and adaptation. Developers run the city. You've got to work with them. Sometimes they can be very prone to inertia. anti-regulation. The benefits are complicated, so public engagement is really important. Just like with trees, there was a good question about AstroTurf, because our schools are starting to replace their fields with AstroTurf, less water, less fertilizer, less resources, but it's hot. So I'd love to hear the answer from you experts about how that balances out. But so some solutions are complicated. And then we operate in silos. We have city government, county government, school boards, state government, and they're not always talking to each other. And so you've got complicated sets of regulations to work through. We need better collaboration. We need more public-private partnerships, because the private innovation can lead the public sector as well. We also have a problem with state regulations. We're required in Charlotte and Mecklenburg to take the lowest bidder. That doesn't mean always the most sustainable bidder. We've got to get past these kinds of state laws. Cities are always looking for money. A lot of times they know all this great stuff, but they're like, okay, great. Tell me where I can find money to do this. And we also have a need to raise public awareness. You know, Denver actually implemented a 25-cent sales tax explicitly for climate solutions. How'd they get that passed? They raised public awareness. Denver is challenged. It has a lot of issues around climate change. It's getting hotter. Summers are getting hotter. They have a lot of need. They did that through a public information campaign. So that is absolutely important. And also, words matter. My last example, and then we could go to questions. We were doing a comprehensive study, environmental quality study for Mecklenburg County, but we knew that certain words are touch points for opposition, for people who don't want change and people who think that environmentalism is only, for Democrats. So we couldn't even call our study Sustainable Mecklenburg. What do we call it? Livable Mecklenburg. So that's my last example. And with that, I will open it to questions.
You're right. Words matter, Mayor. Thank you. I think you raised a lot of good points, and I want to come back. I want to bring Greg back into the conversation and put you on the spot for a moment, if I may, because Greg, I saw a number in the slides that you put up for the city of Baltimore. Was it 1.4 billion was the total cost of the interventions that you were proposing to manage water, mitigate heat risk, and intervene in the context of both buildings and public spaces?
Yeah, it was spread over 30 years.
Spread over 30 years. Okay, well, the time horizon matters. So I want to ask you, a lot of the things that we talked about today inevitably involve prioritization. And so I want to have two parts to the prioritization question. One, if cities are getting in the game, what do they need to do first? And the second element is where. We've had multiple folks in the Q&A comment on lower income neighborhoods. Lucy showed and you commented on the tremendous disparities across geographies and across neighborhoods, and how acute heat and heat stress is in low income neighborhoods. So I want you to talk, and anyone else is also welcome to comment on this, but I want you to talk a little bit about how cities prioritize those scarce dollars in the context of what do they do first, and then how do they elect and how do they make decisions about where to do it first?
Well, it tends to be the squeaky wheel gets the grease. So cities overinvest in wealthy areas that are, more connected. And that's stupid. I mean, the Willie not that I'm advocating in general for criminals, but Willie Sutton was right to say the reason he robs banks is because that's where the money is. The biggest opportunity to cut heat, cut pollution, cut flooding in low income, they're more impervious. So one of the low income neighborhoods we looked at in Baltimore is 5% tree cover. It's 14 degrees hotter than Rollins Park in the north of the city, which is 40% tree cover. The first is, surprise, surprise, low income minority. The second, Rollins Park, surprise, surprise, is white and wealthy. So what people need to understand at the city level, and Jennifer, I think, is educating a lot of mayors about this, is that you want to think citywide. So where do you put your dollar to have heat reduction? Because heat changes or pollution changes, flooding changes don't respect neighborhood boundaries. It affects citywide. If you look at Dallas or Houston, the flooding from that city does not come from increased imperviousness in city. It comes from increased imperviousness outside the city. So you want to overinvest in low income areas for a bunch of reasons, including that it's morally the right thing to do. It is grotesque that people happen to be poor, have to raise children in areas in the summer they're so hot their kids can't be outside, that they can't exercise. A beautiful editorial by Pastor Lamar, this kind of very historic AME church in DC, and US News and World Report in July. It's on our website, about why, as a pastor, he saw this difference between low and wealthy communities, the communities he represented, the low-income communities, and why it's so morally important that there be smart service. So there's a moral argument, which, if you believe in the American dream of equality, of opportunity, we should invest in. But from a fiscal prudency perspective, when you run the numbers, the city has a greatest return, highest benefit cost ratio of investing in smart services in low income areas. So here we've got moral and financial alignment. We have to help our cities understand that and systematically change their policies to make those investments. And they don't do it. You have cities that start to fail right there because their costs go up, their revenue goes down, they get some sort of heat related or flooding crisis, their credit rating goes down, cost of capital goes up, they can't borrow, and now you've got financially failed cities like Detroit. So the way you get out in front of this is you understand city-wise investment opportunities, overinvest in areas that have the greatest benefit, and you've got a story to tell Standard & Poor and Moody's when you sit down on an annual basis, which you do as the CFO of a city. They're like, oh, great, you actually believe in science, check. Oh, you've got a strategy to cool your city, check. Oh, you've got a strategy to reduce risk, check. Okay. We were thinking of downgrading your credit rating because of erosion on the revenue side, and also because of COVID, the revenue from tax from city on sold goods has gone down. But we're actually going to leave your credit rating the same or improve it because you actually are acting like an adult around climate and heat risk.
Mm-hmm. That's a great point. Lucy, I want to let you jump in. I see you have a comment too.
So I agree with Greg. I think we need to go deeper, though. I think a supply and demand sort of framework could offer a lot here. Where do we have services around cooling that are already being provided, already in place, whether that be through green infrastructure or, where is the heat the worst? And where do we have the most vulnerable populations? And
Lucy,
those sorts of
this has been mapped at the city level. So if you do research on it, you'll see where the heat pockets are in cities, and those correlate. One of our partners, the World Cement Association, it's the world's largest cement companies. We're working with them to deliver cement that is more reflective, more porous, and low carbon. We have 25 cities now that are starting to deploy cooling pavements. So you should go to our website to learn about these initiatives, because you're right, you have to engage the private sector. You have to scale the markets and drive more innovation around smart services. That's happening. You can go to our website. You can learn a lot about some of these initiatives.
Mm-hmm. Mm-hmm.
I did go to your website. I thought it was excellent. I think you guys are doing great work. I think that we need to do more of that, though. I've been engaged in lots of conversations with cities and with various planning efforts where that siloed conversation that I think you mentioned really dominates. And the vulnerability, there are so many dimensions of vulnerability. And I think we need to look at more than just race. What's the age demographic? What's the health demographic? What's the access to public transportation? And I think the mayor put it well, that a lot of the choices are made based on lowest bidder. And I think we fundamentally need to blow up that system.
Mm-hmm. Mm-hmm. Mayor Roberts, I see you want to jump in. And then Rao, I want to throw a question to you about our private sector partners. Mayor, please.
Yeah, those private sector partners are important. Absolutely. I think some of the things that both Lucy and Greg were talking about show the importance of public engagement and public awareness. The issue of justice is very real in a number of cities across the country right now. COVID really pointed that out and has given us another measurement and tool, and looking at, yes, we know exactly what parts of our city, they've been the challenge parts of our city for 20 years, 30 years. This is ever since redlining, really, and Jim Crow. Unfortunately, many areas have not grown out of that. And we continue, like I said, inertia is very strong. So public information is important. The other thing Greg mentioned, a faith leader. The faith leaders in our city have been so powerful and have been looking at what's happening in their congregations, looking at the health and the challenges and recognizing that tie to the way the cities have been built, to the surfaces, to the healthy and unhealthy, the hot and the cooler areas of town. And they have been speaking up and connecting that to the numerous movements around the country around racial justice. So that is a powerful moral incentive and imperative that absolutely can be leveraged. But people need to know solutions. I hear all the time people say, well, what can we do about it? And that range of solutions, we need to educate more city leaders, more city staff. City staff can be advocates too, if there are any planners. Our planner has, been really instrumental in looking at a 20-year plan and how we're going to be more equitable, more climate friendly in the future. Unless people bring it up, the climate issue and the health and heat are not at the top of a developer's thinking.
Right,
So
right.
the public has to bring it up, leadership has to talk about it, and then the resources can be allocated.
Yeah, that's a great point to pivot route to you to say, when is heat and health at the top of the list? And is there an opportunity in the private sector for those folks who are tuning in to influence their own industry, to influence their own partners? Here in Boston, we have the Boston Green Ribbon Commission. It's a coalition. It's outside government, but it involves the mayor, but it's really a coalition of the largest property owners and property developers in the city. Our own president, Bob Brown, is a member of the Boston Green Ribbon Commission. And that coalition has been really influential as being a positive source of influence on the city and advocating for change in the context of policy and regulation, and being at the forefront of both mitigation and adaptation measures in Boston. What I'm curious, like how can you see sort of private partners and your clients be advocates for change and even influencing their own community, and then having a positive influence on government actors to affect more aggressive policy?
I'll give you my view and kind of what I've seen over the last dozen years or so. And Greg's been an investor in this. Jennifer's run a city. Lucy's doing research. What I noticed still in the industry is a lot of scapegoating, a lot of people looking after their interests being different from the others. And when I observe that, I see a huge opportunity for people to actually get on the same side. I'll give you just one narrow perspective. From a city point of view, every city mayor I speak to, legislators, et cetera, I always hear a very strong focus on sustainability because that's what their constituents want, and it logically makes sense. Every developer I speak to is looking after their bottom line and saying, how do I attract tenants, fill my building, make it as cheap as possible, and get the maximum revenue? And the funny thing is, those two don't have to be in conflict with each other. Right. And this is where as a technologist, I have a huge bias that technology has a role to play where you can save the planet while making buildings more competitive and more inhabitable. Overall, it actually raises the value of infrastructure in society. Right. If you can create a better quality of life, maybe people would rather pay more for better space and buy something else less, which may be good for society anyway. For example, one of the questions that came up in this panel is, the notion that glassy buildings are bad for the planet. And I know there was a very heavy debate in New York. And in fact, Trump even brought it up in the presidential debate because he knew that a lot of people that enjoy quality of life and people that build buildings want to put a lot of glass in it. But if you vilify them and say, but you're destroying the environment, well, they're saying, because that's what the market wants. And why does the market want it? Instinctively, people would rather have views and connectivity to the outside. And guess what? Medical research proves it, that that's good for humans. So then to go that that's a bad thing, you're going backwards in life, right? Let's go back to the horse buggy, right? So that's not the goal in life. Then I think we should say, how do we create technology that allows people to feel better, live a better quality of life while protecting the environment? And technology is the solution. I'm convinced of that. And I think the key is, how do you foster, Greg worked on it his whole career. How do you foster early stage companies to take risks to create this technology? How do you scale them up? How do you create the framework around regulation? And then, of course, how do you make them so that they're easy to consume and scale up? I'll give you one other narrow point of view. The byproduct of what we do is we create high-tech, high-paying manufacturing jobs in the United States, where our factory is, and we have almost 1 million square feet today, and the several hundred employees, and we're scaling, we're roughly doubling our business every year. Our average wage is more than twice the local wage. So you create modern infrastructure that our children would want, you create high-tech, high-paying jobs, and you drive the economy upwards. So there's a way everything can come together, is my observation. And I'm actually more optimistic. It's happening better today than it did 10 years ago. Greg, I know you have a point of view.
Yeah, it's a great example. And as a CEO of a very successful company, you have a kind of uniquely authoritative voice on this. I mean, I think it's appropriate to acknowledge that there is a very broadly held paradigm, which is, and you even see it in places like the New York Times, well, there's this environmental stuff, and then there's a but that's either stated or implied, and then you get into job loss or adverse economic impact. That paradigm is false for 90% of the time. So as our work, shows, you do green stuff and you create 2 to 3% job increase in Baltimore. Why is that bad for the economy? You make the city more competitive. Why is that bad for the economy? You're increasing revenue. Why is that bad for economy? You're protecting tourism. Why is it bad for the economy? The answer is it isn't. So I think it's very important on everybody on this call to be assertive about breaking the back of this lie, which is it's not environment or jobs. It's not environment, but it's environment and jobs. The way to get to a better economy, better quality jobs, as Rao is saying, is through strategies that are good for the environment. It's not a but or, it's an and. And so really the argument we're making is for fossil fuel advocates, and we subsidize fossil fuels 5 to 8 times as much as we support technologies that are actually good for human health. We're making subsidies that hurt the economy. They're less job creative. They reduce competitiveness. They weaken our economies. And so I think it's important to be super, super, super clear on this point. The things we're advocating for strengthen the economy, strengthen jobs, strengthen competitiveness. Not doing these things hurts the economy, erodes competitiveness, makes it more difficult for cities to raise financing. It's important to get this message through.
Right. And I think, Greg, I'm going to let you have the last word because we are at time. I think this conversation could have gone on for far longer. And I really want to say thank you to all of the panelists. And thank you very much to all of the speakers. I'm sorry I couldn't get to all of your questions, but I know some of our speakers have been trying to respond as quickly as they can in the chat as well. And I hope I got to at least some of the most pressing ones. Thank you to everyone. This has been a really robust and important conversation. A reminder to all of you that it has been recorded and it will be available on the ISD's website and on the YouTube channel. So you can tune back in and look back at the slides that our presenter shared. And I will also just say a final round of thank you to our sponsors, the U.S. Green Building Council, Review Initiative on Cities, and the Energy and Sustainability Club. Reminder, please join the Institute for Sustainable Energy again this fall as a continuation of the Energy of the Future webinar series delves further into decarbonizing the built environment. Next up on November 5th is part 1 of decarbonization of existing commercial buildings, technical issues and opportunities. That will be followed by policy and financial issues on December 3rd. To register, go to bu.edu/ISE/fall21. Thank you so much, and happy Friday, everyone. Bye-bye.